everyone, in this video we will be adding and subtracting rational expressions, and this is the third part. I will put the link of the first and second part in the description box below. In this part, the denominators are not the same, and as you can see here, this denominator here is not in factored form. So there are steps that we need to follow in order that we can add and subtract rational expressions. The first step is to make sure that their denominators are the same. So in this example that we have here, their denominators are not the same. And in order that we can make them the same, we are supposed to factor this out first because we don't see, is there x plus 4 in there? We can't really tell. So then we are going to factor this out using the box and diamond. So I will show the work on the side right here where I will factor this part using the box and diamond. Okay, so this one right here is actually x plus 4x minus 1. So then I go ahead and rewrite this. Again, this one is going to turn this factored form. So I will write that up here. Okay, we are still on the first step. We are supposed to make their denominators the same. As you can see here, again, their denominators are not the same. However, they both have x plus 4. So this first rational expression is missing the x minus 1. So what I would do is I will multiply both the numerator and the denominator with whatever is missing, which is x minus 1. So I will multiply this numerator right here with x minus 1, and then at the same time the denominator with x minus 1 so that we can make their denominators even. So then we go ahead and rewrite this. So this would come out okay, this part right here, which is x minus 1 and x plus 1, we can use the area model so that we can multiply this and simplify it. I will show the work for the area model right here. Okay, so this x minus 1 times x plus 1 is actually x squared minus 1. So I go ahead and write that up here. Okay, since we already have the same denominator, we move on to the second step. The second step is to add or subtract the numerator and keep the common denominator and simplify when needed. So I will show the work on the side right here. So we already have a common denominator, so I will write that up, which is... So then I go ahead and write the first numerator right here, that is x squared minus 1, and then that's a plus, and then I'll put the second numerator, 3x minus 3. So what are we going to do next is we distribute the positive into each of the terms inside the parentheses. So when we distribute that, this would come out. Okay, after this, we are going to combine like terms. So the like terms that we can combine here would be the constant -1 minus 3 is -4. So that we can go ahead and write the numerator as x squared plus 3x minus 4. And that is over x plus 4 times, that's going to be x minus 1. So I combined all the constants here, so that becomes a -4. So what are we going to do next is that we are going to simplify this using the box and diamond. So we can go ahead and get the factor form for this. I will show the box and diamond on the side here. Okay, so this numerator that we have here is actually x plus 4, x minus 1. So I can go ahead and rewrite this as, that's going to be again x plus 4 times x minus 1. So then we can go ahead and divide it with x plus 4, the same thing at the bottom, that's x plus 4 and then x minus 1. As you can see here, both the numerator and the denominator are the same. Now, we are going to use the division by itself property, which states that if we divide a number by the number itself, then the quotient is 1. So this is actually a giant 1 since both the numerator and the denominator are the same. So, which means that this two expressions that we have here when added together is actually equal to 1. Again, that's a giant 1 right there. So this is our sum for these two rational expressions. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, we pretty much have to follow the same step. The first step is to make sure that their denominators are the same. So in this case right here, their denominators are not the same. So then we can go ahead and first factor this part right here, which I will show on the side. Okay, so the factor for this would be x plus 5, x minus 2. So I will rewrite this. Okay, since their denominators are not the same, we have to make sure that their denominators are the same. So in this problem right here, we can see that both of them have x minus 2. But it's missing, this first expression is missing x plus 5. So what I would do is I will multiply both the numerator and the denominator by x plus 5. And then the denominator also gets multiplied by x plus 5. So both of them will be multiplied by x plus 5 so that both numerators are even. So then we can go ahead and multiply this part right here using the area model, which I will show that work on the side right here. Okay, so this expression that we have on top here is actually 2x squared plus 13x plus 15. So I will replace this here. Okay, since their denominators are already the same, we can move on to the second step. The second step is to add or subtract the numerator and keep the common denominator. So in this case right here, they already have common denominator, so I will keep their common denominator. So I'm just going to go ahead and write their common denominator down here. So that is x plus 5 and x minus 2. So what I would do is I will subtract the numerator only. So I will write this first numerator here. So that would be 2x squared plus 13x plus 15 minus, then I will put the second numerator inside the parentheses, 2x squared plus 12x plus 17. And so what I would do next is to distribute the negative to each of the terms inside the parentheses so that we can go ahead and write the simplified version of this as Okay, so what are we gonna do next after we distributed the negative here is we combine like terms. So that's gonna be 2x squared minus 2x squared is 0. So we can go ahead and just cross this out. So it's gone because 2x squared minus 2x squared is 0. Now we also have 13x, we combine like terms, minus 12x is actually 1x, or just pretty much x. So I will show that work on the side right here. So again, 13x minus 12x is just 1x. So I can go ahead and write just x. And then we have the constant here, 15 minus 17 is a negative 2. So I will write minus 2. So I combine them. The 2x squared are gone. 13x minus 12x is 1x, or just x. And then 15 minus 17 is negative 2. And then we copy their common denominator. So that would be x plus 5, parentheses, x minus 2. So what are we going to do next is that you can see here both x minus 2 and x minus 2 are the same. So then we can go ahead and say that we can rewrite this as 1 over x plus 5 times x minus 2 over x minus 2. So that if we multiply their numerators, that would come out x minus 2, and then these denominators here will come out x plus 5, x minus 2. So as you can see here, this x minus 2 and x minus 2 are the same. So then we are going to use the division by itself property, which states that if we divide a number by the number itself, the quotient is 1. So pretty much this one right here is actually 1. So then we can go ahead and write 1 in there, or you can cross this out. So the leftover is 1 over x plus 5. And this is actually the difference between these two rational expression up here. So again, this is 1 over x plus 5. Now others are gonna say, so can we just cross it out and get the answer right away? So yes, you can cross out the x minus 2 and x minus 2, and then remember, when we cross out, it's not 0. So if we cross it out, there's actually 1 in there. So you can just go ahead and say that's still 1 over x plus 5. Did you get the same answer as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!